Uh, Good day, everyone. This is Group 3 of Grade 11 STEM 2, St. Anthony of Padua, and today we are going to be teaching to you the normal standard curve and all of its parts. So, let's please listen to our lesson, and I hope everyone will learn something today. Now, who are we? Well, we are known as the calculus class. We are a group of grade 11 STEM students who like to solve calculus problems and other mathematical problems such as probability and statistics problems. Our grade aid is 11, which means we are in the senior high school. And our members for today, he consists of our leader, Jhay Martinez, our group presenter, me, James Derrick Mayoral, and our two PowerPoint creators, Andrea Orzal and Gian Carlo Saflor. Now, my other group members would also wanted to present our lesson. However, due to time constraints, they were unable to. That is why I am here alone. Now, what are our objectives for this lesson? At the end of this discussion, the students will learn to familiarize themselves with the normal standard curve, meaning the students will know the parts of a normal standard curve, its properties, and other information related to the normal standard curve. They will also learn how to solve a normal standard curve. This would include finding its standard deviation and its mean. And it will also consist of finding the area under a normal curve. Now, what is a normal curve? Well, in summary, a normal curve is one of the most commonly observed continuous random variables that has a bell-shaped probability distribution, or a bell curve. In this curve and its statistics, the middle is the most probable, and the ends are the least probable. Meaning, this is one this is one of the most common observations of random variables. It is known as the normal distribution or the Gaussian distribution. Now, what are its properties? The properties of a normal probability distribution include, but not limited to, its shape, which is just a bell shape. The reason for this bell shape is due to its symmetry on its mean, meaning x here is the mean. X here represents the middle of the curve. This means the curve's peak will always be where the mean is. Now, how about the mean? Well, the mean, median, and mode are all equal. This means if one of them has a value, they all share the same value. Like for example, if the mode has a value of 3, then the median and the mean would also have a value of 3. Now, what else? Well, the spread of the curve depends on the standard deviation. This means the larger the standard deviation, the wider the spread of the curve. Like here in our illustration, the standard deviation, which is represented by this symbol right here, in this curve, it's a 5. That means this curve is not as wide compared to this one, which is very wide, very spread. Now, the tails of the curve, which are here at the end, will flat out indefinitely along the horizontal axis, always approaching the axis but never touching it. This means that the ends of the curve will always try to touch the axis, infinitely approaching it, but never being able to reach it, never being able to touch it. That means it will go on forever. And finally, our last one consists of its total area. The area under the curve will always equal to 1. Meaning, everything that you see here under this curve is equal to 1. That's its area. Now that we know the properties of the standard curve, let's take a look at the standard normal distribution. A normal probability distribution has a mean of 0 and a standard deviation of 1, meaning the peak here is 0 and its interval will always depend on 1, such as 1, 2, 3, 4, and 5, etc., etc. On the right and on the left, we'll have negative numbers due to 0, meaning -1, -2, -3, -4, and -5, etc. onward, to the left. This is the measure of how spread out a normally distributed set of data is. This means this will tell us how spread out the data in this curve is. Now, how to find the area of a normal curve? Well, you must find its z-score first. How to find that z-score? Well, it is usually given in a problem. And it represents the numbers of 1 to 4. However, it only has a capacity of 2 decimal places, and its symbol is the letter Z. For example, here is the problem. Find the area between 0 and Z equals 1.46. Now, now that we have the z-score, now how do we turn it into a percentage to find its area? Well, we use a distribution table. To use it, we have to find the whole number and the first decimal point in their row. This means in our example, which is Z equals 1.46, these two are the rows. These two who we need to find in the first column, which contains the rows. to find the second decimal point in its column. The second decimal point is usually found at the end. The first two, row. The second, column. And in order to find that percentage, we must multiply it by 100 and round off by 2 decimal places. Always 2, meaning like this. Not like this, but like this. Now, here is a sneak peek of our probability distribution table. And if we use our example 1.46 and use the steps, we can find its equivalent in the distribution table. Well, so first step, use the first 2 digits to find the row, which is 1.4. And we have it here. Next, use the second decimal point, which is here, as the column. So, class, if we're doing this and we find this, the second decimal point, it will automatically be 0.06. If 6 is the last, or for example 237, the last is 7, so that means it will be 0.07. So, using the 0.06, we find it here. And using in both our rows and columns, we need to find in the meeting point. The meeting point of the two, the row, which is the first numbers, and the columns, which is the last number. And in order to do that, we got the overlapping one. This is their matching. So, see, 1.4, which is our first one. Then we find the row, which is this one. Then we find the column, which is 0.06 here. And voila, we find the matching one. So, what do we do after that? Well, we multiply it by 100. We multiply this by 100 in order to get the percentage. 1, 2, and the answer is 42.79%. You might be wondering, why didn't I make it into 42.785%? Well, that's because only the first 2 digits of a decimal, meaning we round it off to only 2 digits. Like for example, 98.412. If we given the law of rounding off numbers, and we only round it off to the hundredths place, that means this will remain and this will be cancelled out, meaning it will be 98.41%. And here, instead of 42.785 and the remaining digit next to it is greater than 5 or 5 and greater, we add this one with a 1 and we change this into a 0. So that means 42.79% instead of this. Now, how about negative numbers? Well, it's pretty much the same. We find the first two digits, which is here. Next, we find the second digit, the last one, which is here. And find their matching point, which is 0.42785. However, due to this having a negative, we also add a negative here. Why? Well, this is because if the z-score is a negative, then that means its equivalent will also be a negative. Now we multiply it by 100. Again, rounding off rules. Now, why isn't this a negative? Well, in order to find the area will always have to be a positive. Meaning, no matter if it has a negative sign in front or not, you will have to remove it to get the percentage. Now that we understand and how to find in the z-score in normal circumstances, how about other circumstances? Well, this would be E2. This is the half of the curve. Excuse my poor drawing skills. This is the half of the curve, A1, A sub 1. And this is A. In order to find the shaded area, we must first get the value of both A sub 1 and A sub 2. And since A sub 2 will always be half of the curve, it can also be written as A equals 0.5 minus A sub 1. Now, for example, if our A sub 1 is 0.4279, then of course we find the shaded area by subtracting it from 0.5. And using our calculator, 0.5 minus 0.4279, we get the answer of 0.0721 or 7.21%. That's only if we find the shaded area here. However, if we try to find in the shaded area over here, this is a completely different story. Instead of subtraction, we use addition. Why? Because the area is greater. This area is greater than 0.5. Like for example, find the area. This kind of problems are usually called find the area of to the left of 1.46, meaning to the left of a sub 1. Or find the area to the right of negative 1.46. That would mean from 1.46 to the right. And because of that, we use addition. Because it will be greater than half. If it's here, greater than half. If it's in the negative and it goes to the right, we use this. If it's a positive and we go to the left, we also use this. Now, what if we try to find the middle? Well, we just add the two, a sub 1 and a sub 2. Like for example, if we add a sub 1, which would be, let's say 0.42785 plus 0.32, and we use our calculator, and 32 plus 0.42785, we get the answer 0.74785, or 74.79%. Now you might be asking, but what? But if it's greater than 50%, why did we not use the previous computation equation? Well, that is easy. In the previous computation, we use to the right or to the left. In this computation, we use two different points. We just add the two different points. And this is the same. And this is the same here. Like for example, a sub to the right of a sub 1. The following computations will involve at least 2 points. Like for example, between 0.78, between 0.78 and 2.09. In this type of equation, we use this. Now, what if we find the shaded parts over here at the ends? Well, it would be just the same. Remember, if it's in the shaded parts at the end, we use this. For example, a sub 1, to the right of a sub 1, we have 0 0.7%. And a sub to the left, to the right of a sub 2 would be 0.2%. Add them together and you get 0.9%. Multiply it by 100 and it would be 90%. Yeah, that is how. But if it's 0.07 and 0.02, then it will be 0.09 or 9%. You'll only use this if and only if these are the shaded parts. Okay, so example here. Find the area between in 0.09 and 2.46. Well, following our rules, here is our 0.09, which is 0 here, and 0.09 here, and we get this. Now, we follow this 2.4 here, and 0.06, which is here, and then we get here. We get to here. Its matching point, or its overlap, 0.49305. Multiply both of that by 100, and you get 3.59 and 49.31%. Now, what do we do with that? Since it's finding the area between them, this means 0.09 and then 2.436, and this is our mean, then that means this was our a sub 1 and this is our a sub 2. That means we do subtraction. A sub 2, which is 49.31%, and a sub 1, which is 3.59%, is equal to 45.72%. Therefore, the area of 0.09 and 2.46 is 45.72. And with this is the same. Like for example, 0.09 and negative 2.46. We do this exact same thing, but instead of subtraction, it's addition. Why? Because a sub 1 is here and a sub 2 is here. So that means we add these two. We add these two areas. 39.31 plus 3.59 is 52.9%. Therefore, 52.9% is the total area between 0.09 and negative 2.46. Here is a short activity for you. I will give you 5 minutes in order to accomplish it. If you desire more time, that is fine. You can pause the video. However, I will be grading your work. Ready? Go! Alright, so since 5 minutes have passed, I will be giving the answer to number 1, 2, and 3. So, with number 1, you find in its equivalent z-score, which is 0.35 and 3.09 is 4.99, 0.499. I'm sorry. Then we multiply them by 100 to get a percentage. And since it's combining two areas, here is our, excuse me, sorry, our a sub 1, which is negative 0.0515, I mean 1.05, I'm sorry, and 3.09, we get the answer or of an addition because we're getting in an area from here to here. And if we add 35.31 to 49.9, we get 85.2. Therefore, the answer is 85.2. For number 2, so for number 2, we go 1.0, which is here, and 0.09, which is here, and we find the overlap, which is 36.214. Multiply that by 100 and we get 36.21. Therefore, the area here is 36.21%. Now, for number 3, we try to get 39, negative 3.09, which is negative 3.0 or 3.0 only here, and 0.09, which is here. Find the overlap, which is here. 0.499. And so, since we have our equivalent score, which is 0.499, we multiply that by 100, which moves here too, and cancel out the negative. We get 49.9%. And the area from 0 to negative 3.09 is 49.9%. Or we can round it off to 50%. Half. If you have reached this far, well done po. Aha! Now I reveal to myself that I am not an American. I am a Filipino, actually. I'm just really good at English. If you have reached that far, well done. If you have reached reached a perfect score in our activities, well done. If you didn't, that's alright. Not everyone is perfect. However, with with the right technique and with the right drive, you can strive and be better. Thank you for listening, and we hope that you have learned something from our lesson. I just hope that you'll lose. I mean, you will use this lesson for good, and I hope that this helps you, whether it is a final review video or something of the sorts. It is fine by us. Thank you, and God bless you all.